the question actually is, how did you use the historical control data in interpreting the data that you came up with? To me, it seemed that it was not used in interpretation. And then the question becomes, why did you include it in the slide, and why are you mindful of that historical data?
The historical controls are looked at, in toxicology we consider the concurrent controls to be the best controls. In this case, we know that those controls were handled the exact same way. We know that in this case the animals were individually housed. In most of those other studies, I think only one of those other studies, they were individually housed. We know historically from fisher rats that the individually housed animals, their survivals are much lower. As far as looking at historical controls, we incorporate that into our evaluation. We looked at the percentage to see how low the background rates are, how rare of a tumor this was. And so we did actually look at those historical controls and evaluated that as well, and that we incorporated that into our conclusions.
It seems to me that you probably ought to then go back and kind of relook at the data, because I only glanced, of course, I was just moving through the slides, but it would seem to me that if you do take into account historical controls, then your interpretation of some of the findings is going to have to be changed, because then that means that some of the signal that you were seeing in the results might actually be noise. And one of the comments that I actually wrote in here is that, and it's only a sense of what I'm reacting to. Obviously, you know your data better than I would. When I looked at your results, I get the sense that you're getting drifts in that data set that somehow you're really not able to kind of pin down and explain. Your data, your weight data actually kind of hints to that. There is something going on that you're really not picking up. And tumor occurrence in itself actually gives you a little bit of noise that if you were to use historical controls, in some instances would actually negate some of the conclusions that you put down. So I would just kind of go back and maybe rethink that piece.
So I'd like to comment a moment on the historical control, which, over the years we always look at the historical control, but as Michael said, the concurrent control is always the best control. In this case, the Harlan-Wistar rat, or the Harlan-Wistar, I think, Harlan-Sprague-Dawlium rat, we only have, I think it's 10 or 11 at most, other studies using this rat, none at this laboratory, all done under other conditions, different housing, and so on. So which really makes the use of the historical control it's almost, they're not really historical controls, they're controls from a limited number of other studies done at other laboratories under totally different conditions than were in this study. So that's something to think about. We did look at it. We did look at the totality. You still have a significant, the schwannoma is unequivocally clear. You don't see it in any of the others. The gliomas are, in fact, because in one or two of the other studies, there was a high level of glioma. I don't know if Michael, probably not the time to comment now. We are going in and doing molecular genetic studies, trying to look at the genomic sequences that are present when gliomas appeared in some of the other studies that use this strain of rats, try to get a molecular signature there and compare it to the molecular signature in the gliomas in this study. But that you'll have to wait for the data because it's still very much in the process of being generated. And John wanted to comment on your comment, Ken, about that the glial hyperplasia and the gliomas are not, in fact, the pathology reviews that have been done by veterinary neuropathologists very much believe that these are essentially the same lesion. John?
Yeah, I was just going to say that. So obviously,
you can say it better than I can.
No, probably not. So clearly, when we got this information in from the laboratory, we looked at it. We have had many people, many eyes look at this information, and overall, the conclusion is that you come down to at the end of the day, even taking into consideration all of the information on historical data, the same kind of things that Linda talked about. And you come down to the end of the day, is it more likely that it's related, or is it more likely that it's that it's not related. And the majority of people, and I will say it's not uniform, it's not unanimous, the majority of the people that look at this data set say it's more likely that it is related, that these, certainly the schwannomas, and we have less confidence in the gliomas, they are related to radiofrequency radiation more so than they're not related to radiofrequency radiation. So that's sort of the line at which we've come down on. With respect to the relationship of hyperplasia and the gliomas, hyperplasias, and the schwannomas and the hyperplasias, we have convened, I believe it's 5 separate pathology review groups to look at these lesions. 2 of the groups were charged with the specific question that you raised, which is there a relationship between these two lesion types? And that Michael's correct in that the conclusion was that they are related, that the only difference in these hyperplastic lesions is size, and that they would be considered potentially gliomas if they were to progress. So that's where we were with that. But we took that question to the best experts we could find, and that was their opinion.
Well, that's helpful information. I would still maybe continue to seek additional sort of insight into that, because in my view, the interpretation that's been rendered is contrary to what I have heard, neuro-oncologists, articulate. That said, going back to the issue of historical controls, in light of what Linda said, I would actually then not even make reference to it, because they're not of any value to you in your interpretation of the findings that you have for the reasons that Linda articulated. So in essence, what they do is cloud the issue. If you sort of kind of have that as a backdrop to what you're trying to say, then the last point that I would make is that, and it relates back to this sort of sense of some sort of noise signal that you've got in there. If you notice, when you say that you have more confidence in the schwannomas and in the gliomas, all that goes back really to what your control data was. Because if you look, you actually have higher incidence of those tumors in your control population relative to your treated. And that's what sort of probably is giving you that quote level of confidence.
I should say that with the schwannomas as well, there is a beautiful dose-response relationship that is not as clear in the gliomas.
Yes.
Yeah, I thought I saw a comment over on this side. George, or did you change your mind? Okay, go ahead. Well, we can come back to you.
I may return to this at a later point, but the brain lesions, none of them reached the level of statistical significance. Is that correct or incorrect?
The CDMA exposure for the malignant gliomas was a statistical trend.
At the 6 watt?
Were for all of the exposures.
Oh, it's this trend analysis.
Pairwise comparison was not statistically significant.
Okay, thanks.
Go ahead, one last question.
So if the glial hyperplasia and glioma is a clear continuum, very closely related, then why can't you add them together, which gives you more statistical power? I'm sure you've done that. I'm just asking you what your thought about that is.
And maybe the pathologist would care to comment on this, but the fact that they have delineated size, the difference in hyperplasias and neoplasias in other organ systems is also based on size. For example, in the kidney, the involvement of various tubules, a couple of tubules is a hyperplasia, a few more tubules is an adenoma. So, I mean, this is something that is typically seen in veterinary pathology. I suspect it's also seen in human pathology to some degree, but it's not unusual. And where the pathologists care to draw the line, and they come to an agreement on that line, we stick to that line.